Question 3.1. Consider the infinite geometric series. We have 45, 40.5, 36.45. Calculate the value of the 12th term of the series, correct to 2 decimal places. So we have the geometric series, the first term, the second term, and the third term. So we know the expression of the geometric sequence to determine Tn. So we have the expression of the nth term is Tn is given by A multiplied by R to the power of n minus 1. So A represents the first term, so in that case A is equal to 45. So since they want us to determine the 12th term, so we're going to say n is equal to 12. So how about R? R is the common ratio between the second term and the first term, and it's the same as the common ratio between the third term and the second term, so T3 divided by T2. So we can use any option, we can still find the same ratio. Okay, let's use T1 and T2 to determine R. So I'm going to say R is equal to 40.5 divided by 45. So we get, so the value of R is 0.9. So now to find the 12th term, so we can call it T12, is equal to A, which represents the first term. So we have 45 multiplied by R, which is equal to 0.9. N is 12. 12 minus 1 gives 11. So if we continue further, we're going to have T12 is equal to 14.12. So that is the 12th term. Question 3.2. Explain why this series converges. So the series converges when the ratio is less than 1 and greater than -1. So if the ratio, the common ratio is between these two limits, then the series converges. So we first need to determine the ratio. We have already determined the ratio here, which is 0.9. So we can say that 0.9 is between -1 and 1. So the series converges. So we just need to write this notation. If you have the ratio of 2, you cannot say that 2 is between -1 and 1. So you just need to say the series does not converge. So in that case, the series converges. Question 3.3. Calculate the sum to infinity of the series. So if the series converges, it means the common ratio is between -1 and 1. Then the sum of all the terms from 1 to infinite can be calculated. So we can use this relation to calculate the sum of all the terms up to the infinite. So it's given by a over 1 minus r. So this formula can only be used if the ratio is between -1 and 1. So the ratio should be, the value of the common ratio should be between -1 and 1, so that we can determine the sum to infinity. So a represents the first term, so the first term is 45, and then we say 1 minus r represents the common ratio. So we have determined r in the previous resolution. We get 0.9. So if we compute all this, so we get s infinity, which is equal to 450. Question 3.4. So what is the smallest value of n for which s infinity minus sn less than 1? So we have already question 3.4. What is the smallest value of n for which s infinity minus sn is less than 1? So we have already the value of s infinity, so we are going to say s infinity is equal to 450. So in order to get n, we first need to determine Sn. So if we replace S infinity in this relation here, so we're going to have 450 minus Sn less than 1. So we are going to say, to get the value of Sn, so we need to bring it to the other side. So we can say that f 450 less than Sn. So that is the same as if I say Sn is greater than 450. So here we also have there's something wrong here, so we need to include that 1. So here we have -1 plus, and then we have -1 there. So I'm going to say S and greater than 450 minus 1 gives 449. So we just forgot to include that one, but just rectify now. So we have Sn. So from Sn we can determine the value of n. So here I'm gonna say, since I know the relation of Sn to determine Sn, so I first need to write that relation. I know that Sn is equal to a1 minus r to the power of n divided by 1 minus r. So this formula is used when the common ratio r is less than 1. So here we are going to say, if we replace this relation there, because we have all the values. Okay, we first substitute a, which is the first term, which is equal to 45, and then we have minus, we know what r is, 0.9, and then we have n, and then we say here we have 1 minus r, which is 0.9. So I'm going to simplify this expression a little bit. So that's gonna be, so we haven't yet applied this criteria. We will first simplify this, and then we are going to replace there so that we can determine the value of n in using the inequality. So we have 45, so 1 minus 0.9 . So we have 1 minus 0.9 gives 0.1. 45 divided by 0.1, we get 450. So here we're going to say Sn is equal to 450. So we say Sn is equal to 450, and then we just add this expression. So we have the relation of Sn. I will just replace it there. So I'm gonna say 450 multiplied by 1 minus 0.9, n is equal to 449. Is greater than 449. So now I'm gonna need to solve this equation, this inequality. So we're still doing question 3.4. So we need to solve this inequality here. So how to solve this inequality? Okay, we need to find the value of n. So what we are going to do here is we're going to divide both sides by 450, because since we have a multiplication there. So divided by 450 and then by 450. So on this side we are going to remain with, we're going to say 1 minus 0.9 to the power of n greater than, and this expression gives, so we compute this. If we work out this, we are going to get 0.998, and then we bring 1 to the other side. So we are going to say negative 0.9 to the power of n greater than, so that's 1 become negative. So if we take all this minus that one, we are going to get negative 0.002. So now what's happened is, if we simplify, if we in order to simplify the negative sign, we need to inverse that sign. So we need to change the orientation in order to remove that sign here. So here we are going to say, if we divide both sides by negative 1, so we are going to say 0.9 to the power of n, and then we change. So we can do that only if we divide both sides by a negative number. If you divide both sides by a positive number, we'll just leave it as it is. So now, to determine the value of n, we need to involve the logarithm. The logarithm to make the exponent subject of formula. So here we are going to say to get the value of n, we are going to say log n is equal to log of 0.002, and then we are going to use the base, which is equal to 0.9. So I'm going to have n, which is, so we just need to compute this expression here. So the value of n is 57.98. So now there are two things here. So here we are not solving the equation, but we are solving the inequality. So we need to have a range instead of having just one single value of n. So from this equation, from this inequality, we can say that to get the value of n, we need to involve the logarithm on both sides. So if we say, and then here we are going to use the base, which is equal to 0.9, so that in order to get to bring the exponents down, so we need to use the same base. And then here we have 0.9, so we'll repeat the numbers here. So since the base is less than 1, so it's between 0 and 1, so we're gonna need to change that sign if we simplify. So another way we are going to say, so these two can cancel, so that we are going to remain with n. So I'm going to say n, instead of using this orientation, I'm going to turn it. So now we just need to say log 0.9, and then here we have 0.02. So n will be greater than. So if we compute this value, this expression here, we're going to have 57.98. So that's the value of n. We can change the orientation of this sign if the base is between 0 and 1, for instance 0.5, 0.6. But if you have a base like, let's say 2, you'll just keep it as it is. Same thing here. If you divide both sides, or if you multiply or divide both sides by a negative number, you're gonna need to change the orientation of this sign here, because it was pointing to the right. It was pointing to the right, so now it points to the left because I've divided both sides by -1. But if you divide the side by a positive number, then you can just keep it as it is.